student t-test, which is a parametric test for two samples or groups that are either paired or unpaired in Stata. Student t-test for paired or dependent or related two samples in Stata. Student t-test or paired student t-test is a parametric test that can be used and performed in Stata when we have two sets of data or samples or groups that are paired or related. There are certain assumptions that have to be fulfilled before conducting or using the paired t-test. The first assumption is that the data in each of the groups or samples, the two groups or samples, are continuous and the data are normally distributed, and the difference between the paired groups or samples are approximately normally distributed, and this difference does not have outliers in it. The test can be used to find out whether there is a difference between these two related or paired samples. Here in this Stata data view, I have two variables, untreated and treated. Both these variables are continuous, they are normally distributed, and the participant has been measured at two different conditions. The first condition when there were no treatment, and the second condition when the treatment has been administered. The overall aim of this research study, the data collected from this research study, is trying to examine whether a novel drug have an effect on lowering the systolic blood pressure. So a candidate has been recruited with a high blood pressure for the untreated, and their blood pressure was measured, and then the drug was administered to these participants, and the systolic blood pressure was measured post-treatment. So we have here two conditions, pre-treatment and post-treatment, and in both cases the systolic blood pressure is measured. So the systolic blood pressure is the dependent variable. There are 47 participant or cases, and to find out whether this drug have a significant effect on lowering the systolic blood pressure on those patients, then the paired t-test will be performed, as here the two set of data are paired. To do the analysis, in the command section type t-test for t-test space, then the name of the first variable, which is untreated, and then insert equal sign twice, and then the treated. So this is a paired t-test showing that we have two set, untreated and treated, and we're trying to find whether there is a difference. If you click on enter, a table is generated as shown here for paired t-test. The table shows that the untreated and treated, the observation is that there are 47 participants. Those participant has been measured twice at different conditions. The mean for the untreated is 154, and for the treated is 145.8. 9. So the treated has an average systolic blood pressure lower than the untreated. So there is a hint that the drug might lower the systolic blood pressure in the treated group compared to untreated. A standard error is also given here for both the untreated and treated, and standard deviation for the untreated is 10 and for the treated is 10.8. And also a 95% confidence interval is generated for the untreated and the treated data. And this shows that the mean for the untreated is equal to 154, which is within the lower and upper values of the confidence interval, which give assurance and confident. And for the treated, it's 145.9, which is within the values of the upper and lower for 142.8 and 149.1. So the means for both fall within the 95% confidence interval. Looking at the row which states that the difference, it shows that the difference in the mean between the treated and untreated is 8.08. So there is a difference, and the untreated have a higher mean compared to treated. So, and the difference is 8, so there is a difference, and this difference have a standard error and a standard deviation of 14.9. And what is important here is the 95% confidence interval, and the value of the mean difference of 8 falls within the upper, which is 12.4, and the lower value, which is 3.7 of the 95% confidence interval. So this gives a layer of confirmation that there is a statistical significance that the difference between the treated and untreated and the drug is lowering the systolic blood pressure. Looking at the values here at the bottom, the mean difference is equal to the mean of untreated minus the treated, which is equal to 8.08. And the statistical t-value is equal to 3.7. The null hypothesis is generated and states that the difference between the untreated and treated is equal to 0, i.e. the means for both conditions, untreated and treated, is similar, a degree of freedom of 46. And the null hypothesis, this is for the null hypothesis. For the alternative hypothesis, in our condition here, we look at the mean difference is not equal to 0, i.e. there is a difference in the mean between the untreated and treated, and p-value is generated here, which is less than 0.0005, which is significant. So here we do state that the drug has lowered the systolic blood pressure significantly in the treated group compared to untreated group, as confirmed by the p-value and by the 95% confidence interval. Students, t-test for unpaired or independent or unrelated two samples in Stata. T-test is a parametric test that is performed when there are two groups of data or two samples, and the data in both samples are normally distributed and continuous. There are certain assumptions that have to be fulfilled before conducting or performing the t-test. The first assumption is that the data should be continuous and normally distributed. The second assumption is that the variance are or variances are equal for both groups, or approximately equal for both groups. And the test is used to find out whether there is a significant difference between the two groups based on their means. Here in the Stata data view, I had inserted a data for 100 participants. There are two variables. The first one is the sex, which is categorical, and it have two values in it, or two levels, or two categories, males and females, and another variable which is the height of the participant measured in centimeters. So the height is the dependent variable, and the grouping or the sex is the independent variable, and the data has been checked for normal distribution to find out whether there is a difference between the height for males and females. Then the unpaired t-test will be performed, as here we have two groups or set of data that are independent or unrelated and separate. To do the statistical test, here in the command section, type t and then test space and insert the dependent variable, which is the height. So type height, then comma, and then space, and then by, open a bracket, and type 6 and close the bracket. So this is the standard command for doing unpaired t-test for the dependent variable, which is the height, grouped by the independent variable, which is the gender. And if you click on enter, a table is generated as shown here for the two sample t-test with equal variances, as I had checked the two groups and there is approximately equal variances. And from the table as shown here, the observation for, or the number of cases for male and females are 50, and there are two groups here, male and females, and the mean for the height for the females are 160.4, and for males is 169.4. So males have a higher height, or they are taller compared to females from this initial observation. But yet it is, whether it is significant or not, we will check it with the p-value. And also the standard error is given for the male group and the female group, and the standard deviation is 9.3 for the females and 10.5 for the males. Confidence interval for the mean for the females and the males are given here, and the mean for the females is 160.4, which is fall within the upper and lower values for the confident interval for the female, and for the male, which is 169.40, again it is within the upper and lower confidence interval, or 95% confidence interval. So this also adds another layer of confirming that our observation is genuine. And when we look at the row here, which is the difference between the males and the females, when we find the difference between males and females, it is -9. So here the mean for the females minus the mean for the male. So the male's mean is subtracted from the female's mean, and it is -9. It is -9 because the mean for the females is lower than the means for the males. And a confident interval, 95% confidence interval is generated, and -9 is falling between the two values here, the upper and the lower. So this confirms that there is a difference between the tallness of males compared to females, and the males are taller than females, or the females are shorter than the males, and this observation is statistically significant as confirmed by the 95% confident interval. And if we look here, it says the difference, which is the mean for the females minus the mean for the males. And the statistical t-test, unpaired t-test, is equal to -4.5. And the degree of freedom is 98. And the hypothesis that has been set here is that the null hypothesis states that the difference between the means for the females and males is equal to 0, i.e. that the means for both are similar. The alternative hypothesis here in our case will stick with the alternative hypothesis is that the difference is not equal to 0, i.e. there is a difference in the mean for females and males. So we will look at the p-value here, which is less than 0.05. So there is a this is a significant value, and shows that the difference between the tallness for males and females is statistically significant, as the p-value is less than 0.05.